Hey everyone, welcome to chapter 3 of the Actix Web Rust tutorial, and today we're going to be covering extractors and application state management. An extractor is basically a type-safe way to extract information from your API request. Previously, in the past chapters, we explored how routing works and how you can use different route handlers to create different API routes. However, when you actually want to get data from these routes, you can use different extractors to make this possible. And so the first one you probably want to use is the path extractor. And to access that, you go to the web module and then you do path and then the data type of the path. So for example, if you want to get an ID, then we'd put this path as a U32, and then we can sort of actually just take this value right out of the function parameter and simply return a response. And this works really great. And we can actually test this out. So if we do cargo run, and then if I go to, what was the route, /user/ID, we can see that user ID is 1, and this value was taken from the path parameter. And we can also use multiple values. So if we want to go to user/ID/post/post ID, we can actually just do that. And then you can see user1, post1. Now, instead of using a tuple or a single type for the path parameter type, we can actually use a struct, and this gives just a cleaner and more readable way for having multiple path parameters. And it pretty much acts like an object that you can use and access in your code. And it literally doesn't change the code very much. For this, I like to use Serde. I believe you can manually implement the desterialization of these path parameters if you want, but honestly, you should probably just use Serde. It's very simple. And you can add that to your cargo.toml file by using this code right here. And you also need the derive macro feature. So the next extractor we're going to look at is the query extractor. And this is used for when you have to access URLs with the question mark notation. And this syntax is really simple. You just define your query, and the name of this actually doesn't really matter as long as it's equal to the query struct from the web package, and then you pass the data type you want to use, and then you simply access it using the value on the object. So if I do dot, you can see that we have access to all the type information. And then if for whatever reason it's optional, you can either set a default value using unwrap or you can set that to none. Now to access the request body, you can use the web JSON struct. You can simply pass the type of JSON that you're expecting and then use that type within your function. Actix Web also provides some additional configuration for how you ingest JSON into your API. If you define a JSON configuration, you can actually set limits and handle errors on that JSON. This is really useful for things like public APIs where you allow a user to upload some kind of data, but you don't know this type of data they're going to send. For example, file uploads, if you don't want them to upload more than like 10 megabytes, then you can set that limit here, and you can return some kind of error for your client to use. The next type of common extractor that we have is the form extractor, which is accessed through web form. And this is pretty much what you would use if you're using HTML standard forms. And it pretty much takes in the request and formats it into a valid object that you can use in your Rust code. And the syntax for that is pretty much the same as the other extractors. You can access the form types directly like so. So the next thing we're going to look at is the HTTP request extractor. And this is really useful when you want to access the entire HTTP request object. For example, when you need to inspect headers, the request method, or other metadata in the request that isn't covered in the Actix Web Extractors API by default. And this is honestly really useful for things like authentication and other things that are a little bit more complex than simply path parameters in your API. You can also simply use the request body as a string or bytes if, for example, you are doing some kind of streaming, or if you're simply not working with JSON within your API, then all you have to do is define the type as bytes or string in Rust, and Actix Web will automatically convert your data type in the request body to that type. Next, we're going to look at application state in Actix Web, and application state is actually pretty simple. What you want to do is define some kind of struct that Actix Web will use to track your state. And so here we have a counter, which is an arc mutex. And basically this is saying, hey, we want this integer to be thread safe, which is what arc does. And then mutex basically tells Rust that this data can be mutated by multiple threads. So it's kind of the same thing as marking the value as mutable with the mut keyword. And you can see here that we have this get counter. And what we do is access the data struct in the extractor API. And this will, under the hood, Actix Web will actually ingest our data type in this counter function. You have to remember that Actix Web actually runs by default in multiple threads. So it's important that you don't just, define this value as like not arc in mutex, because you could run into race conditions. And then to actually access the data, you can create a mutex lock on it. You can mutate it like so. And then by default, it'll just get updated. And then inside the main.body, this is where you actually define your application state, and you want to save it into the app data method before you start your server. And this is also the same way, as you'll see in later tutorials, how you can implement a database connection. So for example, if we had, DB, and let's just do like, I don't know, fake. So this is like a fake database, right? And it's not an R struct, but you can have DB fake here, and then you would be able to access your database right inside of this function, and the state will be persisted. It's also possible to use multiple extractors in a single function. As long as you're not using the same type of extractor multiple times, then it's completely valid Actix Web Rust code. Actix Web extractors are derived from the from request trait. And so because of this, it means you can actually extend an extractor and implement your own custom logic. So you have to define these error and future types because Actix Web is an async framework. And then you define the method from request, and you take in a request and a optional payload, and you return a future on that request. The reason you define the future type is because you can actually customize the type of status the future has. So for example, the ready type tells Actix Web that we can immediately execute this feature as soon as it is finished processing. And that is pretty much the basics of extractors in Actix Web. They're a really powerful mechanism that makes writing your API code very simple and ergonomic. So in the next chapter, we're going to go over how to host static content and serve HTML files from your API.